Thank you very much. Hi, everyone. I'm Eun-Pa Lim, working at the Australian Bureau of Meteorology. Here, I'd like to talk about a very rare Antarctic springtime polar vortex warming and weakening event and its impact on the surface climate observed in 2019, and how these anomalous conditions were predicted by sub-seasonal to seasonal climate forecast systems. This presentation is based on a paper 15 co-authors and I published in the BAMS in June this year. My slide is not, oh yes. Beginning in late August 2019, the Antarctic polar vortex circling around Antarctica in the mid to upper stratosphere abruptly weakened and warmed. And these stratospheric wind and temperature anomalies around Antarctica and over Antarctica persisted until mid-December in the stratosphere and moved downward, reaching the surface from mid-October to the end of December. According to these plots from the NASA Ozone Watch page, the stratospheric jet at 60 degrees south at 10 hectopascal level suddenly slowed down from 90 meters per second to 10 meters per second from late August to mid-September, as indicated by this red line. And at the same time, the Antarctic polar cap temperature in the mid-stratosphere increased by 35 degrees from minus 80 degrees Celsius. These magnitudes of wind and temperature changes were very comparable to those of the 2002 event, which is the Southern Hemisphere's only major southern stratospheric warming event that occurred in late September. So these magnitudes of wind and temperature changes in 2019 were in fact unprecedented in the Antarctic stratosphere for late winter to early spring, and therefore all-time records for the vortex weakening and warming were set for September in 2019. And furthermore, this 2019 event set various new records for the Austral springtime mean polar vortex conditions and its impacts. For example, the 2019 September to November mean zono wind at 60 degrees south at 10 hectopascal level was as weak as that of 2002, which was the weakest Antarctic polar vortex on record since 1979. And mid-stratospheric Antarctic polar cap was the warmest on record, with about 50% higher temperature than the previous record set in 2002. And this extraordinary polar vortex weakening and warming together resulted in the highest polar cap ozone concentration and the smallest ozone hole in Austral springtime in 2019 after 1979. Then the weakened stratospheric circulation, the enhanced ozone concentration, and the polar cap warming all work together to cause the surface Southern Annular Mode SAM to be record negative in the following October to December in 2019, as you can see in this bar graph. The SAM is the leading mode of the Southern Hemisphere extratropical circulation variability, which is characterized by an annular pattern of pressure anomalies with the opposite signs between the mid and high latitudes, caused by north-south shifts of the high latitude jet and associated storm track. For example, this map shows the negative phase of the SAM with low pressure anomalies in the middle latitudes and the high pressure anomalies in the high latitudes, which is caused by an equatorward shift of the eddy-driven jet and associated storm track. This negative SAM tends to impact the southern hemisphere subtropical climate by pushing the downward branch of the Hadley cell a few degrees equatorward during the southern hemisphere warm seasons, therefore enhancing downward motion and associated adiabatic warming and increasing the incoming solar radiation with reduced cloud cover. And these changes are especially very pronounced over Eastern Australia by causing hot and dry conditions during its spring and summer seasons. And this was the case in 2019 with record strong negative SAM in October to December and extreme hot and dry and severe bushfire conducive conditions in subtropical Eastern Australia. For example, to better understand the large-scale climate drivers of the Australian bushfires in its far eastern seaboard in late spring 2019, we averaged the Australian Forest Fire Danger Index east of the 150-degree east, where the bushfires were the most ferocious. This index takes into account temperature, low-level winds, humidity, and soil moisture. We regressed this forest fire index onto the detrended El Nino Modoki index, detrended Indian Ocean dipole mode index, detrended springtime stratospheric polar vortex index, and a long-term linear trend for 1979 to 2018. And then we scaled the regression coefficients by the 2019 magnitudes of the predictors. What we've learned from this statistical model is that more than half of the observed forest fire danger index anomaly over the bushfire struck region was explained by the natural mode of the large-scale oceanic and atmospheric circulation variabilities. And about half of that naturally explained variance was accounted for by the record-breaking stratospheric polar vortex weakening and associated negative SAM. Then how well did we predict the 2019 stratospheric polar vortex weakening, the negative SAM, and its relationship with Australian hot and dry late spring climate conditions? For the prediction of stratospheric polar vortex variations, we assessed the skill of the hindcasts for 1990 to 2012 and the real-time forecast for 2019 for September to December, produced from these 5 major operational forecast center models: BOM, ECMWF, JMA, NASA, and the UK Met Office models. These forecasts were initialized with high-quality observed atmosphere, land, and ocean conditions of July to early September. Our predictand was the Austro springtime stratospheric polar vortex index, which was formed by the September to November zonal wind anomalies at 60 degrees south and 10 hectopascal level. Over the common hindcast period of 1990 to 2012, spring stratospheric polar vortex anomalies were foreseeable from late June to early July by a few models. And these anomalies were skillfully predictable as indicated by this correlation skill greater than 0.6 from late July to early August onwards. Being consistent with this hindcast skill, the significant weakening of 2019 spring polar vortex anomaly, the weakening of the polar vortex was predictable from mid-July 2019, and its extremity, as indicated by 2 standard deviation negative anomaly, was predictable from about mid-August onwards. Then for the prediction of the negative SAM and its simulated relationship with the springtime stratospheric polar vortex weakening and Australian temperature and rainfall, we analyzed the real-time forecasts of the Bureau of Meteorology's S2-1 forecast system called S2-1. Here, the red color bars show the observed monthly mean SAM anomalies from August 2019 to January 2020. And the minty, blue, purple, and black color bars show the forecast monthly mean SAM anomalies when the forecasts were initialized from late July to early September. And you see here that the negative SAM in October and November were predictable from late July, which was the time when the significant weakening of the stratospheric polar vortex was predictable. And XSS1 ensemble member forecast suggested the weaker the stratospheric polar vortex was predicted, the more negative SAM of October to December was predicted. And the more negative the SAM of October to December was predicted, the warmer and drier Eastern Australia was predicted, which was entirely consistent with the results from our statistical analysis. So to summarize, a rare stratospheric polar vortex sudden warming and weakening occurred over Antarctica in September 2019, and the resultant weakening of springtime mean stratospheric polar vortex at 60 degrees south and 10 hectopascal level made the near record, and the associated low stratospheric warming was indeed the record breaking. And the stratospheric polar vortex weakening caused the negative SAM in October to December in the troposphere, which contributed to extreme hot and dry, and so bushfire conducive conditions over subtropical far eastern Australia in late spring 2019. Then we found that the significant springtime stratospheric polar vortex weakening was skillfully predictable from late July 2019 by the state-of-the-art S2-S forecast systems of the 5 major operational forecast centers. And the October to December mean negative SAM was also skillfully predictable from late July thanks to its linkage to the extreme weakening of the stratospheric polar vortex. And this skillful forecast of the negative SAM positively contributed to the prediction of extreme hot and dry climate over Eastern Australia in late spring 2019. Thank you very much for your attention, and for more details can be found in the paper. Thank you.